number. So we have 0 to 9, these 10 digits. Then we have A, B, C, D, E, F. So if we have numbers from 0 to 9, they can be used by these digits. Then 10 can be, the 10 will be represented by A, 11 will be represented by B, and so on. 16 will be represented by F. Other numbers, for other numbers, we will use combination of these different digits. In this particular course, that this would be sufficient. For us, we write numbers in decimal. This is the natural way of writing numbers in decimal number system, and how computer understands, that is the binary number system. So we will be discussing only these two. Okay, so let's start with the most commonly used and the natural way of representing numbers, that is decimal number system. As told, this it uses 10 digits to represent any number. Combination of these 10 digits can be used to represent any number. And when we talk about number systems, we have positional number system. What do we mean by positional number system? That is, a weight is associated with every digit position, and that weight represents the relevance of that particular position. For example, let's take an example, 653. We write 653 in decimal number system like this. This is base 10, and this 10 represents decimal number system. When we talk about binary, we write base 2. Okay, 2 for binary. So suppose we have this number 653. This is 653. Or I can, the weights associated with this is 1, 10, and 100. So how we read this? We have 3 units, 5 tens, and 6 hundreds. Okay. And when we add all these weights with the respective digit, we multiply these weights with the digit and add them together, we get the original number. Okay, is it clear? So in decimal number system, we have these weights. Base is 10 and the power starts with 0. So this is units, tens, and hundreds, and so on, thousands, 10,000s. Now, if you will see, what do we say that what these weights represent? These weights represents the relevance of this particular position. This has weight 1 and this has weight 100. Okay, so this digit with higher weight is called as most significant digit, and the digit which has least weight out of these 3 digit is called as least significant digit. Okay. So this is what we understand. This is what we are. This is the way we are looking at numbers from the time we started learning about mathematics. Okay. So this is the natural way. The another number system is binary number system. In binary number system, we use only two digits. We have just two digits, and combination of these two digits can be used to represent any number. In binary number system, these digits are also called as bit. So 0 bit or 1 bit. Okay. And these, suppose we have this number in binary number system. Here we have base. So weights will be 2 raised to power 0, 1, 2 raised to power 2, 2 raised to power 3. Okay. So this has least weight. This is here, this is most significant digit, or in case of binary number system, we called is this is the least significant digit. In binary number system, we call it as least significant bit. This bit has the highest weight associated with it. So this is called as most significant bit. Is this clear so far?
Yes, ma'am.
Okay. Now, to compute the decimal representation of this binary number, what we do, we multiply each bit with the corresponding weight and add them together. So in decimal number system, how we will write it? 8 into 1 plus 4 into 1 plus 2 into 0 plus 1 into 1. Okay. And this is 13 in decimal number system. Is this clear to everyone?
Ma'am, can you repeat?
So this is my binary number. If I want to find the corresponding decimal number representation of this binary number, what I will do is I will uh, multiply the weight with the corresponding bit and add all them together.
Okay, ma'am,
So
got.
okay, so if you got it, this this is one example. Just try it on your own. What is the decimal number representation for this binary number? Don't type the answer in chat box. I will ask you separately.
मैम
Yes.
मैम तो बाइनरी में तो एक ही डिजिट को रिप्रेजेंट करने के बहुत सारे तरीके बन सकते हैं।
हाँ हाँ, वो अभी हम आगे करेंगे.
ओ
So those who have done, just type done. Don't type the answer, just type done. Okay, Garvika, what is your answer?
Ma'am, 41.
Okay. Any other answer other than 41? Is there anyone who is getting something else as output? Everyone is getting 30 or 41? Okay. So this is, and this is 32 plus 8 plus 1, which is 41. Is this clear?
Yes, ma'am.
Now let's talk about how many bits with n bits, how many distinct value can be represented. Right now we are talking about only positive integer numbers. Okay, we are not considering negative integer numbers as of now. We are just talking about positive integer numbers. So we talk about their representation range. So if I have n bits, with n bits, I can represent 2 raised to power n distinct values. And the range of these values is from 0 to 2 raised to power n minus 1. So suppose I have 2 bits, how many distinct value I can represent using these 2 bits? I can represent 2 raised to power 2, that is 4. And the range of the numbers which can be represented by these 2 bits is from 0 to 3. Okay, so 0 0 0, so with these 2 bits I can represent 4 distinct value which ranges between 0 to 3. Is this clear? With n equals to 4, how many values I can represent? I can represent 16 distinct values which ranges from 0 to 15. Is this clear to everyone?
Yes, ma'am.
Yes,
Good.
ma'am.
Yes, ma'am.
Okay. Now, your question. Don't type answer, just type done if you have got the answer. If you have solved the question, just type done, don't type answer. Your question is, first convert this number, this is a binary representation, convert this into decimal. We have already done this. Okay. Now find how many bits would be sufficient to represent twice of this number. So how many bits would be sufficient to represent twice of this number. Okay, Khushi, what is the output?
Ma'am, 7.
How you got 7?
Ma'am, the closest power of 2 that would include 82 in it. So that would be 2 to the power 7,
Yes.
128.
Yeah. So with suppose if I take n equals to 6, what is the range of numbers which can be represented? It would be 0 to 63. Okay. If I take n equals to 7, the total the range of numbers which can be represented are 0 to
127.
127. And this number is 41. Twice of this number is 82. So this can be represented using at least 7 bits. Is this clear?
Yes, ma'am.
Yes, ma'am.
Yes.
Okay.
मैम 2 टू पावर 7 के लिए बिट्स 8 नहीं चाहिए होंगे? 2 की पावर 0 से शुरू होता है ना?
2 to power किसके लिए?
2 टू द पावर 8 के लिए 2 टू द पावर 7 के लिए 8 बिट्स चाहिए होंगे ना?
The number of bits are 7, no? This is 7 bits. So how many distinct value can be represented are 2 raised to power 7.
ओके.
That is 128. But we are also including 0. So range will be 0 to 127. Now this is all about the representation in decimal and binary. And we have also discussed how to convert a binary representation into decimal representation. And then we have also discussed how many bits or how many numbers can be represented using n bits. Okay. Now let's discuss, suppose we have a decimal number and we want to obtain its binary equivalent. So how to do that? So how to find binary equivalent of a decimal decimal number. Okay. So what we do is we divide the decimal number by 2 and again we divide the obtained quotient by 2. Okay. We keep on dividing the obtained quotient by 2 until the obtained quotient is equals to 1. Okay. So let's take an example. Suppose I have this number 18 and I want to find its binary equivalent. What I will do is I will divide this number by 2 and I will divide the number by 2. So this is my quotient. 9 is my quotient. Okay. I take this 9 this and again divide it by 2. So I have 4 as quotient and 1 as remainder. Again I take 4 divided by 2. I have 2 as quotient and 0 remainder. Again I take 2. So I have 1 as quotient, 0 as remainder. Since when we have 1 as quotient, we will stop here. Okay. Now your binary representation includes this quotient 1 and the set of these previous remainders in reverse order. So this is my binary number. That is 1 0 0 1 0. Is this clear? This is my number. I will divide it by 2. I have this quotient 9. I'll take this quotient and again divide it by 2. I keep on dividing the quotient, obtained quotient by 2 until I get quotient as 1. I will stop here and this is this quotient 1 and rest of and the previous remainders in reverse order gives me a binary equivalent of the decimal number. Okay, so 1 0 0 1 0. Is it clear?
Yes, ma'am.
Yes,
So,
ma'am.
ma'am, is this representation is by the minimum bit?
What do we mean by minimum bit?
Ma'am, we can represent 18 by like this number has 5 bits, so we can also represent it by 6 bit by adding an extra 0.
हाँ, whenever इसके लिए हम अभी बात करेंगे, whenever we represent numbers, no, integer numbers or maybe negative numbers, we have this number of bits fixed. That integers can be represented by maybe suppose 1 byte or 2 bytes. So if suppose I have 1 byte reserved for a positive integer, this is just an example. So I have total 8 bits. So this is my number, which is occupying 5 bits, and remaining will be 0. So in 8-bit representation, this will be the binary equivalent of 18. Is it clear?
Ma'am, I didn't understand this 8-bit.
We say that whenever we have integer numbers, maybe positive numbers or negative numbers, we allocate memory के बारे में कल पढ़ा था ना, it is divided into cells. So we allocate a fixed number of bits to store each number. ठीक है? Suppose for positive integers, we have decided that it can be stored it can be represented using 8 bits only. ठीक है, तो हम उतना ही नंबर रिप्रेजेंट कर सकते हैं जो 0 से 256 की रेंज में आ जाएगा, 255. Suppose I have 8 bits, so I can only have integers in the range of 0 to 255. Okay. Now suppose I have this number 18 and binary equivalent is this, which consists of 5 bits as of now. अगर मेरा 8-bit representation है, which is already allocated for my integers, so the remaining bits will be 0. So this is the 8-bit integer, 8-bit binary representation of number 18. ठीक है? अगर मेरे को कभी डेट स्पेसिफाई करनी होती है जिसमें 2 ब्लॉक्स होते हैं DDMMYY के फॉर्म में, सो सपोज आई राइट 11 and if I want to write July with a number, so instead of writing 7 I write 07. ठीक है? The same way, if 8 bits are allocated for representing integers, so remaining bits will be 0.
But then how would we know that in how many bits we should represent the number?
जनरली हर स्टैंडर्ड में, हर एक प्रोग्रामिंग लैंग्वेज में, अभी तक हमने पाइथन की बात करी थी, उसमें देयर वाज नॉट अ लिमिट टू रिप्रेजेंट like how many bits are allocated for representing numbers. But when we talk about C, each type of value has fixed number of bits or bytes assigned to it. Like for integers we have 8 bytes, so हम 8 bytes तक जितनी रेंज में वो नंबर आ जाएगा वो ही allocate कर पाएंगे. अगर हमको और कोई बड़ा नंबर चाहिए तो then we have to declare, we have to define that this is suppose a longer number. वो कैसे डिफाइन करते हैं that we will come to see, or that we will discuss when we will talk about data types in C. Okay, this is just the foundation. ये हमको कैसे पता चलता है, ये मोस्टली सिस्टम के बेसिस पे और प्रोग्रामिंग लैंग्वेजेस के अकॉर्डिंग दिस हैज ऑलरेडी बीन डिसाइडेड कि दिस टाइप ऑफ नंबर will be represented using this amount of bytes or bits. Okay, is it clear? Yes.
Yes, ma'am.
तो यहाँ तक क्लियर है ना that how to represent numbers in from decimal to binary.
Yes, ma'am.
Okay. Now, when we study about number system, one of the important component is the adding binary addition. How to add binary numbers? So suppose we have only bits in binary representation, binary number system. So sum of 2 bits. So if we add 0 bit with a 0 bit, output will be 0. If we add 0 with 1, output will be 1. 1 plus 0 is 1. 1 plus 1, it is 0. Current step bit is 0. And carry to the next step is 1. So this is written like this. This is current step bit 0 and carry to the next step 1. Okay, let's understand this with an example. Suppose I have this number 1 0 1 0 0 1 0 1. This is 1, this is 1. 1 and 1 is 1 plus 1 is 0. Current step bit 0 and carry to next step is 1. Okay. Now this is 1 plus 0 is 1. Again 1 plus 1 is current step bit 0 and carry to the next step is 1. Again 1 plus 1 is 0, current step bit 0 and carry to the next step is 1. Now 0 and 1 is 1. 1 plus 0, 1. 1 plus 0, 1. 0 plus 1, 1. 1 plus 0, 1. 0, 1, 1 and 1. Is this clear? How?
Can you bring the last third one from the left? हम एक बार फिर से पूरा ये 10 से जहाँ पे करंट स्टेप बिट 0 और कैरी टू द नेक्स्ट स्टेप 1 यहाँ से प्लीज।
ओके ओके। 1+1 क्या होता है? करंट स्टेप बिट तो हो गई 0 और नेक्स्ट कैरी बिट कौन सी हो गई हमारी? 1. So it is 0 carry 1 in easy language. Then 1 0 is 1. इसका आउटपुट क्या आ गया? 1 plus 0 is 1. So this is 1. Now 1 plus 1 again is 0 and carry to next step is 1. Again this 1 plus 1 is 0, carry to next step bit 1. This 0 plus 1 is 1. Then it is simple. 1 plus 0, 1. 1 plus 0, 1. 0 plus 1, 1. 1 plus 0, 1. 0 plus 1, 1. And 1. Is this clear now?
Ma'am, where did this come from?
Where did what come from? These rules?
Yes, like 0 plus 0 is 0, but 1 plus 1 is carry to the next step 1 and current step bit 0.
These are like mathematics में कैसे होता है? 2 plus 3 हमने 5 है, तो these are the design things, like these are the designing rules कि अच्छा हम 1 plus 1 is 0 carry 1. So these are the standard rules.
मैम अगर ये तीनों वैल्यूज को डेसिमल में कन्वर्ट करें तो वो रूल भी एप्लीकेबल हो जाएगा?
अभी हम डेसिमल की बात नहीं कर रहे. Right now we are only talking about integer addition. We are only considering and that's so positive numbers. अभी हम negative numbers पे भी नहीं जा रहे हैं.
मैम बट ये 0 और 1 तो वोल्टेज का दिखाते हैं ना कि हाई वोल्टेज या लो वोल्टेज, तो ऐसा मैथ्स में इसको कैसे रिप्रेजेंट कर सकते हैं?
क्या है? रजिस्टर्स है. रजिस्टर्स में क्या होगा? सिर्फ दे विल अंडरस्टैंड ओनली बाइनरी नंबर्स, बाइनरी वैल्यूज. तो उनको क्या होगा? 1 0 0 1. अगर अब मेरा ऑपरेटर एडिशन ऑपरेटर है, सो दिस इज द वे इट विल ऐड टू नंबर्स. ओके, इज इट ओके?
या मैम ओके.
Okay, so just try this on your own. These are two numbers and you have to add it. Don't type answer in chat box, just type done if you have solved this. What is the binary addition of these two numbers, and also find the decimal equivalent.
मैम
Yes.
नंबर भूल जाएंगे मैम जब तक पूरा बन जाएगा.
क्या? Sorry, वापस बताना.
Ma'am, I am saying that I'll forget the number by the time I reach the last number.
याद क्यों रखना है? कौन सा वाला याद रखना है? बाइनरी में एडिशन करते वक्त? Okay, Yashvardhan Saraswat, have you done it?
Yes, ma'am.
You have done it?
Yes, ma'am.
Okay, tell me the output. Tell me your answer.
मैम 1 1 1।
अच्छा, इधर राइट साइड से बताओ।
अच्छा राइट
राइट
साइड क्या?
राइट टू
हाँ
लेफ्ट।
0 0 1 1 1 0 1 1 1।
And what is the decimal equivalent?
मैम ये कैलकुलेट लिखा है।
So is this the output everyone is getting, or someone is getting different output?
मैम 239।
239.
No, ma'am,
246।
238. Ma'am, 238 is right.
238 is
238.
correct.
238.
238.
या मैम 238।
238 जा रहा है मैम।
और बाइनरी में एडिशन में यही आ रहा है सबका, या कुछ डिफरेंट आ रहा है?
यही है
Yes,
मैम।
ma'am.
मैम यही है।
ओके। Now, till now, we were only discussing positive integer numbers, how to represent them in binary numbers. Now, let's talk about negative integer numbers. And we also call them signed integer numbers. जो positive integer होते हैं, we call them unsigned integers. And for if we consider negative numbers, they are called as signed. Signed integers include both positive and negative integer numbers. They can be +5, -5. Okay. Now, how to represent these signed integers? For that, we have 2's complement. Now, what do we mean by 2's complement? Suppose I have this number 127, and in 8-bit 2's complement, this number will be written as okay. This is 8-bit representation. Now, in this 2's complement, this most significant bit, the bit which has highest positional weight, this most significant bit is called as sign bit. Okay. If the value of this sign bit is 0, it represents positive number. If the value of this sign bit is negative, this is considered as this represents a negative number. Okay. Now, how to find the negative? How to find binary equivalent of -27? उसके लिए what we have this number which represents +127. So I have this number 0 1 1 1 1 1 1 1. In the first step, we invert all the bits. मतलब I will take its not. Not ले लिया तो क्या हो गया? Invert कर दिया तो 0 will become 1, 1 will become 0. This inversion of bits is called as 1's complement. Okay. Now we take 2's complement of this number, and to find out the 2's complement, we add 1. So what will be the number? So this is my minus 127. And if we see, this most significant bit is 1, which represents negative number. Is this clear? Is this clear how to find out 2?
Ma'am, please explain again.
Okay. So this is my binary representation of 127, and I want to find out the binary representation of minus 127. So what I will do is I will first take the ones complement. Ones complement means I will invert these bits. So 0 की जगह 1 आ जाएगा, 1 की जगह 0. So after inversion, after ones complement, I get this number. Now to find the binary equivalent of this negative minus 127, we need to take 2's complement. 2's complement में हम क्या करते हैं? We just add 1 to 1's complement. So this is my 1's complement. I add 1. So 0 and 1 1, बाकी सब में as it is आ जाएगा. So this is the 2's complement, or I can say the binary representation of minus 127.
Excuse me, ma'am.
Yes.
Ma'am, this same bit, minus 127, it also represents 128 if it
वो अभी हम
not.
बात करते हैं उस बारे में.
Okay.
Is this thing clear to everyone?
Yes,
This much? Okay.
Yes, ma'am.
Now, this is how we get the 2's complement. Now, how to find the range of numbers which can be represented using n bits? When we were considering only positive integers, we said that the range will be 0 to 2 raised to power n minus 1. Okay. Now we have negative numbers as well. So how to check means what numbers can be represented using n bits? So suppose we are taking n bits as example. Okay. So the one way to identify what positive and negative integers can be represented, one way is first check for 0, then check for 1, minus 1, 2, minus 2, and so on. Now, instead of finding binary equivalent and then check the range, we directly move to 128. Okay, can you find the binary equivalent of 128? What is the binary equivalent of 128? Is it correct?
No.
It is wrong?
Yes, it's 127.
Remove 1 0.
I'm 60 रहेंगे.
Okay, sorry.
No,
60 क्यों आएगी? 7 है.
मैम 7 ही आएंगे.
सही है मैम.
Yeah.
सही है.
Okay. So what will be its ones complement? Can you find its 2's complement? Everyone just find its 2's complement.
मैम बट 128 के लिए तो 7 बिट चाहिए ना.
But 8 बिट्स है ना, आई एम टेकिंग 8 बिट, तो 8 बिट्स हैं। अब बताओ कि इसका 2's कॉम्प्लीमेंट क्या होगा। Just quickly find out what is the 2's complement of this number.
Same.
Same.
Ma'am,
Same.
same.
Can I write like it?
Same.
Can I write like this? This is what you are getting.
Yes, ma'am.
Yes, ma'am.
But this is the big ambiguity, no? We cannot have same representation for two different numbers. So either we can use this representation for 128 or we can use this for minus 128. Now how to find it out?
I'm
So
one negative.
you एक second, just hold on. I am writing it like this. This is my question mark. It is either 128 or it is minus 128. ठीक है? अच्छा, 1 का 2's कॉम्प्लीमेंट क्या होगा? 1 का बाइनरी इक्विवेलेंट क्या होगा? And what will be its 2's complement? What will be the 2's complement of 1?
हम लास्ट
Last
में
में
1
zero
0 आ जाएगा।
Hmm?
हम
0
लास्ट 2 डिजिट्स में 1 0 हो जाएगा। 0
0000010।
ये होता है? चेक करो एक बार।
No, ma'am, all one, last one 0.
All.
No, ma'am, all one.
Ma'am, all one, yeah, all one.
देखो
One
देखो
All one.
All one. All one.
Yes.
कंफर्म श्योर?
Yes, ma'am, all one.
Yes, ma'am, all one.
So this is my minus 1. Okay. You only have find out that this is minus 127, representation of 127, binary equivalent of 127. Minus 1 का क्या है? All 1. Now what will be out this? Which two numbers should be added so that I get minus 1 as output?
minus
Shall I
128.
add 128 or shall I add minus 128?
Minus 128.
So if I'll add minus 128 with 127, I'll get this output minus 1. So a good choice for this representation is minus 128 and not 128. Okay. So the range of n bits, n with 2's complement is minus 2 raised to power n minus 1, 0 and 2 raised to power n minus 1 minus 1. Is it clear?
Yes, ma'am.
Yes, ma'am.
मैम तो आगे 1 को देखकर ही पता लगा सकते हैं ना
हाँ, आगे 1 को
कि
देख के लगा सकते हैं हम कि दिस शुड, क्योंकि हमने पहले ही डिस्कस कर लिया था कि इन 2's complement we just wanted to verify it कि whether what we are saying is okay or not. हम आगे 1 को देख के भी ये अंदाजा लगा सकते थे कि it can't be a positive number because sign bit is on. Okay, but this is another way of looking at it.
Ma'am, so what would be the binary equivalent of 128?
So for that, we need one more bit. We can't represent 128 using 8 bits. We need 9 bits to represent 128. Okay?
Ma'am,
Yes.
on this last one, range of n bit.
रेंज ऑफ n बिट था ना कि हमारे पास में हाफ है. अगर हमारे पास में 8 बिट्स हैं, if we are only considering positive numbers, then we can represent 2 raised to power, this is the range, 0 to 2 raised to power n minus 1. अब हमारे पास पॉजिटिव नंबर्स भी हैं, हमारे पास नेगेटिव नंबर्स भी हैं. ठीक है, तो हम हाफ, अब इसमें कितना होगा, 0 to 255 8 बिट्स में. अब मेरे को इसको हाफ करना है. I can have 0 to, either I could have 128 here and minus 127 here, or other way round. So मैंने जो भी अभी ये चेक किया है, this was just to find out कि which range is correct, this one or this one. Is it okay?
Okay, ma'am.
So when we talk about 2's complement, if we have 8 bits, so 7 bits will be used to represent any number, and the sign bit, the most significant bit, will be used for representing the sign.
मैम तो साइन बिट को हम लोग को 2 रेज टू द पावर में नहीं लिखना होगा ना?
मगर बिट्स तो हमारी वही है ना कि 8 बिट्स हैं. अब 8 बिट्स हैं तो what is the range of numbers which we can represent? That is this thing. Okay, ये वही चीज कर रही है. इसने ऑलरेडी एक बिट को माइनस कर दिया, साइन बिट को उसने ऑलरेडी माइनस कर दिया. So we have only 2 raised to power, we have only 7 bits. Okay.
Ma'am, so to convert binary equivalent into a decimal, we should not use the sign the
वो
sign
अभी
bit.
है, वो हम कल की क्लास में डिस्कस करेंगे. सपोज वी हैव बाइनरी इक्विवेलेंट एंड वी हैव दैट नंबर इन टू's complement form. That number could be positive number or a negative number, and now we want to find out its a decimal equivalent. How to do it? Since time is less now, so I'm not discussing it. We will discuss in tomorrow's class. We don't have class. We will discuss it Monday's class.
Ma'am, tomorrow you said you are going to take a extra class.
I'll take extra class on next Saturday. अभी इस वाले Saturday में there are chances of more admissions. 5th को एक special round है LNMIT में admissions के लिए. So I'll take, if some students will join in our batch, in our section, so I'll take an extra class on Saturday, the coming next Saturday.
Okay, ma'am.
Yes.
थैंक यू मैम. मुझे कंफ्यूज होगा मैम, इससे पहले में आपने इसे रेंज 8 बिट की रेंज 0 to 255 है, और इधर 8 बिट की रेंज -127 to 1.
नेगेटिव नंबर्स भी है ना उसमें. जब हमने 0 to 255 लिया था तो सिर्फ पॉजिटिव नंबर्स हम कंसीडर कर रहे थे. नाउ वी हैव नेगेटिव नंबर्स.
मैम फाइनली क्या ट्रू है, मतलब 8 बिट क्या रिप्रेजेंट, कितना रिप्रेजेंट कर सकता है?
वो क्वेश्चन में गिवन होता है. When we will learn C, तो ये you will realize कि we can define certain numbers कि नहीं, हम positive numbers ही consider करेंगे. This program will read only positive numbers. तो उस केसेस में हमारे पास में अगर सपोज हम इंटीजर को 8 बिट से रिप्रेजेंट कर रहे हैं, तो हम 8 बिट्स को हम नंबर को रिप्रेजेंट करने के लिए यूज कर सकते हैं. सो इफ वी हैव पॉजिटिव नंबर्स ओनली, वी डिफाइन दैट वी आर यूजिंग कंसीडरिंग ओनली पॉजिटिव नंबर्स, वी कैन यूज ऑल 8 बिट्स फॉर रिप्रेजेंटिंग नंबर्स. सो वी कैन रिप्रेजेंट 0 to numbers ranging from 0 to 255. अगर हम ये बोल रहे हैं कि we are considering negative numbers as well, and we have 8 bits only, so the 7 bits will be used for representing numbers, and one extra bit will be used for sign bit. तो हमारे पास जो numbers होंगे वो they will be less. Okay.
मैम तो ये 2's complement पे डिपेंड करेगा कि हम रेंज को किस फॉर्म में रिप्रेजेंट करते हैं.
हाँ, मतलब हम ये टूज कॉम्प्लीमेंट पे नहीं डिफाइन कर रहा है, ये इस पे डिफाइन कर रहा है कि हमारा नंबर साइंड है या अनसाइंड है। अगर अनसाइंड है सो वी विल यूज द नॉर्मल रिप्रेजेंटेशन जो हमने पहले देखा था। अगर वो साइंड है तो फिर वी विल रिप्रेजेंट दैट नंबर इन टूज कॉम्प्लीमेंट फॉर्म। और अगर क्वेश्चन में कुछ जनरली अगर कुछ इस तरह का क्वेश्चन आता है कन्वर्जन का, तो इट विल बी गिवन कि दिस नंबर हैज बीन रिप्रेजेंटेड, दिस बाइनरी नंबर हैज बीन रिप्रेजेंटेड इन टूज कॉम्प्लीमेंट फॉर्म। ओके,
So, ma'am, in question it will be given that it is signed or non-signed.
either it will be given that it is an unsigned integer that you have to consider only positive numbers, then the range will be 0 to 255. If it is given that it is an unsigned integer, then the range will be different. And how to convert this binary number, the binary two's complement number into decimal number, that we will see in next class. Okay.
थैंक यू मैम।
Okay.
मैम टूज कॉम्प्लीमेंट का भी तो मतलब वही हुआ ना कि उसको नंबर को साइन के साथ कैसे लिखना है, मतलब टू
हाँ,
कॉम्प्लीमेंट
हाँ,
वही रिप्रेजेंट करता है।
हाँ,
तो मैम मतलब वही डिसाइड करेगा कि नंबर साइन है या अनसाइन।
हाँ। टूज कॉम्प्लीमेंट में साइंड है अनसाइंड है हम वो बिट से देख लेते हैं, बट अगर हमने यही बोल दिया कि हमारा तो पॉजिटिव नंबर ही है तो हमको टूज कॉम्प्लीमेंट में लिखने की जरूरत ही नहीं है नंबर को।
तो मैम वो ऊपर प्रोग्राम में स्पेसिफाई करना पड़ता है।
जनरली हम एक्चुअली ये हम नंबर सिस्टम इसलिए पढ़ रहे हैं ताकि हम सी को अच्छे से समझ पाए, डेटा टाइप्स को अच्छे से समझ पाए। तो जब हम अभी तक हमने बात नहीं करी है पाइथन में इस तरह की, बट जनरली मोस्टली प्रोग्राम्स में हम डिफाइन करते हैं कि हमारे प्रोग्राम में अगर सिर्फ पॉजिटिव नंबर्स की जरूरत है तो हम उसको डिफाइन कर देते हैं ताकि हमको ज्यादा स्पेस मिल जाए, ज्यादा नंबर्स को हम रिप्रेजेंट कर पाए। ओके,
ओके मैम, थैंक यू मैम।
ओके,
Thank you, ma'am.
ओके, ओके।